Have you ever looked at a rock and wondered, what's its story? I mean, really wondered. Because what if I told you that every single stone, every grain of sand, is like a page in Earth's own diary? A diary that details everything: catastrophic floods, ancient rivers, vast forgotten oceans. Well, today, we're going to become geological detectives. So let's just dive right in. How do we actually crack this code? How can one single rock tell a story about an entire landscape that disappeared millions of years ago? That is the mystery we are going to solve together right now. And here is our mission briefing. We have 5 case files to investigate, and each one reveals a different piece of the puzzle. We'll start at the base of a mountain. We'll follow a river all the way out to sea, dive deep into the ocean's abyss, and even trek through an ancient desert. And by the end of this, you'll have the toolkit you need to read the geological record for yourself. All right, let's open up our first case file, From Mountain to Plain. We're on the scene of a sudden, really chaotic event right at the foot of a huge mountain range. This is a place where a story of immense energy has been written in stone. Okay, so our first piece of evidence is something called an alluvial fan. The easiest way to picture this is to imagine a super fast-moving stream, just loaded with rocks and sand, barreling down a steep mountain. The second it hits the flat ground at the bottom, boom, it loses all its speed and just dumps everything it was carrying. And the result is this really distinct fan shape of debris. So let's break down the evidence here. First off, the sorting is just terrible. You've got big boulders, little pebbles, sand, all jumbled up together. The rocks themselves are sharp and angular, which tells us they haven't traveled very far at all. But the real smoking gun is this weird, coarsening upward layering. Now think about it. You'd expect the heavy stuff to be at the bottom, right? But here, the coarse, heavy material is on top of the finer stuff. This happens because as the fan builds up over one flood after another, the source of the debris gets closer, so bigger rocks can get carried further out onto the fan. It is a dead giveaway for this environment. Okay, so let's move to our next case file and see what happens next. We're leaving that chaotic mountain base, and now we're going to follow the evidence on a long, winding journey downstream, carried along by the slow, persistent power of a river. So how does a river work like a giant conveyor belt for all this evidence? Well, it uses 3 main methods. The big stuff, the bed load, just kind of rolls and bounces along the river bottom. The much finer particles, like silt and clay, are the suspended load. They just float along in the water. And then you have some minerals that are completely dissolved, carried invisibly as the dissolved load. So after this really long journey, where does all of that rock and sand and silt end up? Well, it gets dropped at the river's mouth in a formation we call a delta. This is what happens right where the river meets a big body of slow-moving water, like a lake or the ocean, and it's forced to just drop everything it's been carrying for hundreds of miles. And what's really cool is that not all deltas look the same. Their final shape is kind of like a signature. It tells us exactly what force was in charge at that location. When the river's current is the strongest force, you get this classic bird foot shape, like the Mississippi Delta. But if the ocean waves are stronger, they smooth the coastline out into a nice arc, like the Nile Delta. The shape itself tells us who won the epic battle between the river and the sea. Okay, it's time to take our investigation offshore. Case file number 3 takes us deep into the vast, mysterious world of the marine environment, from the sunny continental shelf all the way down to the dark, crushing pressure of the abyss. You might think the ocean floor is just, mud that washed off the land. But oh no, it is way more complex. Look at this chart. It shows all these wild sources of sediment. Sure, a lot of it is terrigenous, meaning it comes from land, but an almost equal amount is biogenic. We're talking about the shells and skeletons of countless tiny marine organisms just raining down from above. Then you've got stuff that forms right there in the water, volcanic ash, and, get this, even a tiny fraction that comes from space dust. Now, this brings us to a really, really important clue called the carbonate compensation depth, or the CCD. The easiest way to think of it is as this invisible line deep in the ocean. Above this line, all those tiny calcium carbonate shells can safely settle on the seafloor, and over millions of years, they become limestone. But below that CCD line, everything changes. The incredible pressure and the higher acidity of the deep water literally dissolve those shells before they ever get a chance to be preserved. They just vanish. So what does this mean for us detectives? It means
If you find ancient limestone, you know for a fact that part of the ocean was once shallower than that CCD line. It's a fantastic clue about ancient sea levels.
So, we've seen what a sudden burst of water can do, and what a long river journey does. Now let's look at a completely different force. For Case File 4, let's investigate the unique signature left behind by wind in an ancient desert. The evidence board for a desert tells a completely different story. Unlike that chaotic jumble from the mountain flood, wind is a meticulous organizer. It creates excellent sorting, which just means all the sand grains are pretty much the same size. They're also really well-rounded from constantly bumping into each other, and they have this unique frosted look on their surface, kind of like sea glass. This is the clear fingerprint of a very precise and patient force. And here it is. This is our aha moment. Let's compare the signatures side by side. On one hand, you have the desert, shaped by wind, which gives us perfectly sorted, rounded grains. It's highly organized. On the other hand, you have the alluvial fan, shaped by a sudden flood, giving us this chaotic, jumbled mess of poorly sorted, angular rocks. Two completely different forces, leaving two completely different and unmistakable fingerprints in the rock record. So, after going through all the case files, what's the verdict? We've gathered the evidence, we've connected the dots, and now you have the fundamental knowledge to start reading the geological record for yourself. So here it is, your brand new geological detective toolkit. From now on, when you're out in the world, you can ask these questions. Are the rocks all jumbled and angular? You're probably looking at an ancient mountain base. Are the grains smooth, rounded, and all the same size? That tells a story of a long journey down a river. Do you see limestone? That's your clue to a former shallow sea. And if you see that perfectly sorted, frosted sand, that is the unmistakable fingerprint of an ancient desert. It really reminds me of that amazing quote from the conservationist Marjorie Stoneman Douglas. The earth writes an autobiography. The rocks are its pages. And now, you have a much better idea of how to actually read those pages. So, I'll leave you with this one final thought. Now that you can spot the clues, the sorting, the shape, the composition, what story are the rocks in your own backyard, or your local park, or on your next hike really telling you? The planet's diary is open, and it's just waiting to be read.